Hello and welcome to a video on solving quadratics by factoring. So today we're going to solve them by graphing and solve by factoring. So a reminder from Algebra 1, solutions to a quadratic equation, those are going to be called your x-intercepts. So if it ever wants you to solve a quadratic, you're essentially looking for the x-intercepts. Now, x-intercepts have many different words in algebra. So they can be called roots, they can be called zeros, and they can be called, again, solutions. So if it asks you for any of these terminology, it's wanting you to find the x-intercepts. So if we have a graphing calculator, it's actually pretty easy. So first part, I want you guys to graph these in your calculator. So press pause and give me a rough sketch of what these three functions would look like. Press pause. All right, so if we graph these, I'm going to graph the first one in my calculator. You should have gotten something like this. And so since we're looking at our x-intercepts, it crossed at a 1 and it crossed at a 3. And so that's roughly what your graph should look like. The middle one and the last one, if you graph them in the calculator, look like the following. So if I want to find the solutions using my graphing calculator, all I have to do is look at the x-intercepts. So the first solution would be x equals a 1, and the second solution would be x equals a 3 for your first graph. You can leave it like this, or you can use what is called curly brackets. They are above, they're right next to P on your keyboard if you hit Shift above the bracket symbol. This middle graph only hit the x-axis once. It kind of repeated hitting it at a 2. So there's only one answer, x equals 2. Again, you could put that in a curly bracket if you wanted to. Totally up to you which one you would like to do. This last one did not hit the x-axis at all. So this is actually no solution, or there are no solutions to this problem. So those are the three things that can happen. Your quadratic can hit the graph twice, meaning that there will be two real solutions. In future math courses, you're going to learn about imaginary solutions, but we're going to stick to the real ones for Algebra 2. Your graph can hit the x-axis once, which would mean there is one real solution, or it could not hit the graph at all, meaning there are no real solutions. So these are actually imaginary, which again, you will learn in a future math course. So that is how you can use your graphing calculator to find the answer. Now, if you didn't have a graphing calculator, you would need to do this by hand. So one way to do this by hand is to factor. And so we're going to talk about that. Okie doke. These steps to factoring a quadratic. Number one, you have to make sure it's in standard form, which means that all your terms are to one side and your equation is set equal to 0. Then you're going to factor. We used the t-chart, we've used the x method before in Algebra 1, and then you're going to solve. So let's do this first one together. I've got x squared minus 4x equals 45. So step 1, my equation does not equal 0. I need to move this 45 over to the left side with its other terms. To do that, you're going to do the opposite. So subtract 45 on both sides. Now you cannot subtract 45 from an x or an x squared, so you're just going to rewrite the problem. I would have, bring down your first term, x squared, middle term, minus 4x, and then this minus 45 would equal to 0. Now, if you notice a pattern, when 45 moves to the other side, all that happens is it switches signs. So if you can do that step in your head, feel free to do that step in your head. So now, I've got a quadratic. This is a easier quadratic because I don't have a leading coefficient. It will be a 1. So this is kind of a shortcut problem that we talked about from our last video. So to factor it, I'm going to do my t-chart. Remember, in your t-chart, you've got your a times your c on the left side, and you have your b term on the right side. So in this problem, our A is a 1 times 45, or times negative 45 is negative 45. And my B term would be negative 4. So I'm trying to figure out what multiplies to get the number negative 45 and will add to get the number negative 4. The only thing that multiplies to get 45 is 9 times 5. Now, how do I multiply and get a negative number? Well, one of these numbers has to be negative. So we can kind of guess and check. If I put a negative in front of the 9, what is negative 9 plus a 5? Well, that actually gives me my answer of a negative 4. If that gave me a positive 4, what you could do is switch it. So for example, 9 minus a 5 would be a positive 4, which does not work out. So if this left number is negative, you have to guess and check to see which number would work out. So negative 9 times a positive 5 is my solution. Since my A is a 1, I can jump straight to putting these into my parentheses. So I'm going to jump over here. So I'm going to take x minus 9, put it in a parentheses, x plus 5, put it in a parenthesis. Again, you can only do this shortcut when your A value is a 1 in front. So we have factored the problem now, but now I have to solve it. So when I am solving, I'm going to set each factor or parenthesis equal to 0. So I'm going to set the first one equal to 0 and the second one equal to 0 and solve. So my first equation is x minus 9 equals 0. My second equation is x plus 5 equals 0. And then I just go back to algebra and solve a one-step equation. The opposite of minus 9 is plus 9 to both sides. 0 plus 9 is 9. So x equals 9 is my first solution. Over here, opposite of a plus 5 would be minus 5 to both sides to get x equals negative 5. So you can leave the answer like this, or if you wanted to, put them in your nice little curly brackets. Now, if you did not want to do this work every single time, a shortcut is you can switch your signs. So when you are setting something equal to 0, you're essentially just doing the opposite, which switches the signs. So if your parenthesis says x minus 9, I know the x-intercept would be a positive 9. Same thing here, if it says plus 5 in parentheses, it'll be a minus 5 for your x-intercept. So if you want to remember that shortcut, great. If you want to do the math every time, also great. So that is an example of how you solve by factoring when your A value is a 1. Let's talk about another example. Oh no, that should be covered. So our second example, spoiler, that'll be in a part 2 video. So we are going to solve by factoring this left one over here. Notice I only have 2 numbers, which looks a little bit different from my 3-term trinomial. So it's going to be a little bit different. Typically, you want to move your terms on the right to the left. However, I noticed that my leading coefficient of my quadratic is negative, and when you factor, you typically want your leading coefficient to be positive. So instead of subtracting 27x and moving it to the left, I'm going to add 3x squared and move it to the right. That would give me a positive quadratic, which is typically what you want when you're factoring. So after moving this to the right, I cannot combine these because I have an x and an x squared, so I'm going to rewrite them. Make sure you write your x squared term first. So I've got 3x squared plus 27x equals 0. So I only have 2 terms, which means I cannot do the t-chart and factor my trinomial. When you have 2 terms, you are going to find the greatest common factor, or GCF. So the biggest number that goes into 3 and 27 is a 3. Then you have to see how many x's they have in common. They've got 1 x in common. So the greatest common factor of these 2 terms is a 3x. After you have your GCF, you are going to factor or reverse distribute this problem. I've got 2 terms, so I'm going to have 2 terms in my parentheses. So I'm going to ask myself 3 times what is 3? That's a 1. And then x times what is x squared? So x. Then I'm going to try and get to a 27. So 3 times what is 27? That would be a 9. And I don't need an x term because I already had one on the outside. So 3x times a 9 would be a 27x. So you have successfully factored these two terms. The next step is to set each parenthesis equal to 0 and solve. So my first equation would be 3x equals 0. My second equation would be x plus 9 equals 0. Now, if you've got one term out here, you're going to divide by 3 on both sides. 0 divided by anything is going to be 0. So if you only have one parenthesis with nothing in the first parenthesis, this value is always going to be a 0. Because dividing by anything 0 divided by anything will be 0. Over here, we're going to minus 9 on both sides. And again, you could just flip your sign and know that one solution is x equals negative 9. So again, if you wanted to leave it like this, you could, or you could write it in your beautiful curly brackets. So we've covered how to factor using two terms and how to factor using a equals 1. I'm going to save this lovely problem for part 2. So go ahead and leave this video and watch part 2 on how to solve this crazy hard factoring problem.